Okay, so ang gusto nating makita ay ano na tayo, no? Recap natin. Ano nang alam natin sa derivatives? Alam na natin kunin yung derivatives ng polynomials. So we just usually apply the power rule. And syempre, nakita naman natin yung ano, no, yung ang tawag dito, yung pupuntahan ng ibang functions natin, yung mga sine and cosine. Syempre, we need to get an idea ng derivatives din nila. So, dun tayo pupunta today and let's start. Pero before we actually evaluate the derivative of our trig functions, starting with sine and cosine, let's review a couple of topics or items from limits. So let's recall from our discussion on limits, tinignan natin yung limit ng dalawang expressions na to. We looked at the limit as, well, we used x. Sige, let's use x. As x approaches 0 ng sine x over x. So, paulit-ulit to nating kinover, no, before. So, pwede bang palagay na lang sa GC kung ano yung result niyan? Okay, thank you, Zarina. It's 1, di ba? Sine x over x. Yung limit niya is 1. Ang next natin na kailangan ay ito. Ito I don't remember kung na-discuss natin. So, I'll just go ahead and evaluate this. So, kailangan natin tong dalawang limits na to para mahanap yung derivative ng sine. So, first, the limit as x approaches 0 ng sine x over x that's equal to 1. And yung limit of 1 minus cosine x over x is x approaches 0. Ang gagawin natin dyan ay magmumultiply tayo ng conjugate ng numerator. So, we will multiply 1 plus cosine x sa both numerator and denominator. So, yung denominator natin magiging ganito. Kaso, if you look at the numerator, it's just a product of the sum and difference of two terms. So, magsisimplify siya into a difference of two squares. So, the numerator will become 1 minus cosine squared x. Our denominator doesn't change. It's still x times 1 plus cosine x. Pero, ano ba ang 1 minus cosine squared x? Pakilagay sa chat. It will be sine squared x. Huwag na nating parang split yung difference sa mga mali. Kung mali. Huwag tayong mahiya. Okay lang yun. We write this limit as x approaches 0 of sine squared x over x plus 1 plus cosine x. Ang gagawin natin ay split natin yung sine squared x sa numerator para maging sine x over x times sine x over 1 plus cosine x. So, remember, sa limits, no, pwede natin siyang i-distribute over terms. So, we could rewrite this as limit as x approaches 0 of sine x over x times limit as x approaches 0 of sine x over 1 plus cosine x. What can we say about yung left na term? Yung limit, okay, it's 1. No, not term, left na factor. So, this goes to 1. Tignan natin yung second na factor. Can we evaluate this limit? Kung 0 over 0 siya, then we need to do something else. But let's see. What is sine 0? 0. So, sine 0 is 0. But what is cosine 0? It's 1. So, hindi siya 0 over 0. It's actually 0 over 1 plus 1. So, it's the entire thing, yung hinahanap natin na sa left side, it's equal to 1 times 0 or it's equal to 0. So, etong limit na to, yung 1 minus cosine x over x as x approaches 0, this is equal to 0. Okay, and now we're ready to find the derivative of sine x. So our first task is to find the derivative of sine x. So, de-derive natin to, no? But after this, kumbaga parang memory verse na lang siya. Dapat maalala na natin na ang derivative ng sine ay ito. Parang ganun. And to do this, we'll let f of x be equal to sine x. So, when we look for the derivative of f of x, we will use the limit definition of the derivative. So, we'll use the limit as delta x approaches 0 of sine. So, f of x plus delta x, no? So, sine of x plus delta x minus f of x or sine x. all over delta x. So, ang titignan natin dito ay yung sine x plus delta x. It is the sign of a sum. So, we will use the sine sum identity. Hindi ko natatanong kasi baka matagalan tayo. But remember, sine a plus b is equal to sin cos plus cosine. So, we will expand yung sine x plus delta x. We'll write it as sine x cosine delta x plus cosine x sine delta x minus sine x. So, we'll just continuing with the numerator all over delta x. Now, ang manipulation na gagawin natin sa kanya ay o-observe natin that yung sine x dito at yung sine x dito, pwede nating i-combine by factoring out. So we'll factor out, we'll combine and factor out. So it will be limit as delta x approaches 0 of sine x. Ito yung matitira, cosine delta x. Tapos, i-combine natin siya dito. So, magiging minus 1. Plus, yung hindi natin ginalaw na term sa numerator, cosine x sine delta x. Then the entire thing is all over delta x. Ang next na gagawin natin is we'll split the fraction. Meron pa rin tayong limit. Then we'll split the fraction. Yung first part will be sine x times cosine of delta x minus 1 all over delta x. So yan yung left side. And then another limit as delta x approaches 0, yung right side naman, that will be cosine x times sine delta x over delta x. Do you see kung saan tayo papunta? Okay daw, sabi ni Yanis. Sige. So, pumunta na tayo doon. Yung limit, ikakalat ulit natin sa factors. We'll have limit as delta x approaches 0 ng sine x times the limit as delta x approaches 0 of cosine delta x minus 1 over delta x plus the limit as delta x approaches 0 of cosine x times the limit as delta x approaches 0 of sine delta x over delta x. Now, ano yung alam na natin na limits dito? From our results dito sa taas, yung limit as x approaches 0 of sine x over x is equal to 1, then correspondingly, the limit as delta x approaches 0 ng sine delta x over delta x is also equal to 1. This goes to 1. Next, yung limit as x approaches 0 ni 1 minus cosine x over x, nagmamanifest siya dito, pero baliktad yung cosine delta x, yung 1 minus, naging cosine minus, imbis na 1 minus cosine, cosine minus 1. Pero okay lang yan. Kasi para lang natin siyang ginawang negative, limit of negative 1 minus cosine delta x over delta x. But that is equal to 0 anyway. So, kahit negate natin to, this is still equal to 0. Now, yung sine x dito, wala naman siyang delta x. So, ang limit as delta x approaches whatever na wala naman delta x should be itself. So, this goes to sine x. Same argument dito, wala namang delta x yung cosine x. So, walang effect yung limit. This is just equal to cosine x. So, ang result natin will be sine x times 0 plus cosine x times 1, giving us the result, giving us the result na ang derivative ng sine x ay equal sa cosine x. Memorize. We need to memorize this. Gusto kong parang ipa-visualize, no? If we take a look at the graph of sine x, and we want to talk about its derivative, then i-consider natin yung slopes, no? Yung slopes ng tangent line sa bawat point. Now, if we take a look, let's take a look dito sa sa 0. Ang slope natin dito nung tangent line, I think you could visualize it to be equal to 1. Kasi siya papataas siyang ganun eh. 1 siya, then the slope slowly, again, we're here. The slope of the tangent line is 1. Then as we move up dun sa sa slope, as we move up the function, notice the slope is still positive, no? Pero pababa ng pababa until umabot tayo ng slope natin dito na 0. So 1, pupuntang 0 dito, then bababa until maging -1, then mag-0 dito. Well, kung babalik tayo sa Desmos at ipa-plot natin yung graph ni y equals cosine x, cosine. Pansin natin na dapat yung grid natin siguro para mas visible gawin natin step na pi over 4. Tignan niyo yung again, hindi ko hindi makita yung yan. So andito tayo sa point na to. The slope is 1. Tignan niyo yung cosine function. It is also at 1. Then habang umaakyat tayo sa graph, bumababa yung slope pero positive pa rin until mag-0 dito sa pi over 2. Kung saan 0 yung value ni cosine. And then the slope goes down. Notice dun sa blue na curve, negative yung ating negative yung ating values, meaning the slope of the tangent line is negative until we get to pi. Then sa pi, -1 yung slope at -1 din yung cosine. And then hanggang bumaba siya na mag-flatten ulit and it starts to go up, the slope of the tangent line starts to go up. Dito, 0 yung 0 yung corresponding value ng cosine, meaning 0 yung slope ng tangent line. So, interesting na yung cosine at yung sine, pareho silang shape and they also describe yung slope ng tangent lines ng isa't isa na medyo maayos. Now, yung next nating i-derive na derivative is yung derivative ng cosine. And looking at the two curves, yung blue yung cosine, yung red yung sine, would you say that the derivative of cosine is sine? Kasi kung ang derivative ng cosine ay sine, edi 0 dapat yung slope ng tangent line ni cosine dito. At 0 naman si sine. 0 din yung slope ng tangent line dito. Pero 0 din naman, 0 naman yung sine. Pero kasi tignan natin, ano yung slope ng tangent line dito ni cosine? Is it positive or negative? Negative, di ba? Negative yung tangent line, yung slope ng tangent line. Pero positive yung values ni sine. So, hindi equal to sine yung derivative ni cosine just by looking at the graph. So, we'll now move sa pagkuha sa kanya using yung long method. But ang maganda kasi sa sine and cosine, looking at these two graphs, you could see na sobrang related, no? Nung derivatives nila. Like, the behavior of the sine is also tells us the behavior of the slopes of the tangent line. So may guess si Jude, it's negative sign. That's actually correct. So yan dapat yung puntahan natin, negative sign. Want to find the derivative of cosine. So we'll start with f of x equals cosine x. And so f prime of x is the limit as delta x approaches 0 of cosine x plus delta x minus cosine x all over delta x. So again, meron na naman tayong trig sum, like cosine x plus delta x. So expand natin siya using our sum formulas for cosine. So cos minus sin. Cosine x, cosine delta x, minus sine x, sine delta x. Tama ba yung sunod ko? Minus cosine x all over delta x. Para lang clear, pag shinare ko tong notes, ito yung, palitan ko yung kulay niya, na siya yung in-expand natin. So again, maghahanap tayo ng pwedeng i-combine at i-factor out. So we're looking at cosine x dito, cosine x dito. I-combine and factor out natin sila. You'll get limit as delta x approaches 0 of cosine x, pinactor siya, yung matitira ay cosine delta x minus 1 minus sine x, sine delta x all over delta x. So same yung gagawin natin dun sa ginawa natin sa sine kanina, which is we'll split the fraction, then yung cosine delta x minus 1 over delta x, then another limit, and you should see where this is going. Yung limit, ayusin na natin. I-further split ko pa yung limit over the factors. Pero you should see no how we will arrive at negative sine x. Kasi yung limit as delta x approaches 0 ng cosine delta x minus 1 over delta x, which is this one, pupunta siya ng 0. This goes to 0. Yung limit ng sine delta x over delta x as delta x approaches 0, pupunta siya ng 1. This has no delta x, so pupunta to ng cosine x. This has no delta x, so pupunta to ng sine x. And ang result natin will be cosine x times 0 minus sine x times 1. Giving us na ang derivative ng cosine x ay equal sa negative sine x, which is, again, nahulaan natin looking at the graph. But if we take a look, at the graph again, kung lalagyan natin to ng minus, at binantayan natin yung behavior ng points ni cosine. Again, blue yung cosine, red yung negative sign, 0 yung slope ng tangent line sa taas. Then, as the point moves here, it has a negative slope of the tangent line, which corresponds to negative values naman ni sine. Until mag-hit tayo dito, ito yung pinakamataas na slope or pinakamababa kasi negative. Parang it starts to naging steep din. After this kasi, di ba, it starts to flatten out na. So, mag-hit tayo nung minimum na slope, which is negative 1. Then it starts going flatter. So, uma-approach na siya ng 0. So, negative pa rin yung slope. Pero dito, palapit na siya ng 0. Until mag-flatten tayo dito, yung tangent line, at 0 na rin yung value nung negative sine x, which is yung derivative natin. So, madaling tandaan, no? As ang sine at cosine, they're more or less the derivatives of each other. Derivative ng sine ay cosine, derivative ng cosine, sine din, pero negative. Okay? So, we're now looking at the derivative of tangent. And essentially, we want f of x to be equal to tangent x, and we're looking for f prime of x. Pero note na ayaw na natin gawin yung mahabang yung mahabang limit of the difference quotient for tangent. Kasi alam na natin ang derivative ng sine at cosine. At si tangent, it's just sine x over cosine x. So, ano pwede natin gamitin? Meron tayong product rule, meron din tayong quotient rule for differentiation. And this is a quotient. So, we will just use the quotient rule. So, f prime of x, let's recall yung quotient rule, low di high, meaning yung denominator times the derivative of the numerator. Low, so cosine x, times the high, the derivative of the numerator. So, sulat muna natin na ganito. Minus high, the low, meaning times the derivative of the denominator, over low, or over the denominator squared. Now, the derivative of sine x is cosine x. So, diretso na tayo doon. And the derivative of cosine x is negative sine x, all over cosine squared x. But what do we have here? We'll have cosine times cosine, or cosine squared x, minus sine times negative sine. So, magka-cancel yung dalawang negative, magiging plus sine squared x. Ano yung numerator na yan? Thank you, Enrico. It's 1. Nauna si Enrico. So, it's equal to 1. So, this is just equal to 1 over cosine squared x. And cosine squared x, 1 over cosine squared x is secant squared x. So, the derivative of tangent x is equal to secant squared x. Unfortunately, gagamitin natin to, pati yung derivative ng secant, cosecant, cotangent, which we'll do sa AA, gagamitin natin to hanggang grade 12. So, you will really have to memorize itong mga derivatives ng 6 trigonometric functions. Like, dapat mabilis natin siyang mare-recall. Hindi na natin gagawin itong mga derivation kasi i-memorize na natin sila. Let's just take a quick look at the graphs of tangent and secant. If we take a look kay tangent x, ang slope ng tangent lines niya laging positive. Kasi kahit saan ka pumunta dun sa graph ng tangent x, essentially increasing siya eh. It's always an increasing function every time within the subintervals na may graph. Siyempre, pag tumawid siya nung asymptotes niya, parang re-reset siya sa baba. Or one way I like to imagine this, parang mag-go siya all the way to positive infinity, then iikot na siya ulit sa baba, negative infinity, para parang naglo-loop siyang ganun. But anyway, magulo pa yan. But notice, everywhere na defined siya, it is increasing. So, necessarily, kung titignan natin yung graph ng derivative niya, which is secant squared x, they all have to be positive. Wala tayong values that are negative. Yung isa pa nating pwedeng observe is that yung pinakamaliit na slope, yung pinakamabagal siya mag-increase, ay kung saan siya tumatawid ng x-axis. Dito. Right? Kasi mas dito, you can imagine that the tangent line is steep. Then it gets a bit flatter, then it goes steep again. So, yung pinakamababang value ng derivative niya should be located here sa 0, sa pi, 2 pi, 3 pi. Basically, kung saan 0 yung tangent function. If you take a look at secant squared, it is indeed na, dun nga pinakamababa yung graph ng secant squared. And in fact, it's equal to 1. So yung slope ng tangent function dun sa x-intercepts niya, yung points dun sa x-intercepts, yung slope ng tangent line nun is 1. And bago siya pumuntang 1, it's greater than 1. Yun nga, di ba? It sort of slowly goes down. The slope goes down, but it's still positive. Then mag-hit siya ng 1, then it goes steep again. At yun naman din yung behavior na dinedemonstrate ni secant squared. Like, it's always positive, pero lumalapit ng 1. Pag nang hit ng 1, magiging steep ulit yung slope. So, more or less, consistent naman tayo. Kung gusto nyong maghanap ng problems for practice, yung isang na-discover ko na mabilis gawin, nagtatanong na lang ako kay ChatGPT, give me problems on derivatives of sine, cosine, and tangent. So, if you're trying to review, that could be something that you could do. Can you give me 10 items on derivatives of sine and cosine? Ganyan. With polynomials. And yun, it comes up with a bunch of practice exercises that I could give you or you could do as practice. So we shouldn't be afraid of new technologies. I know some teachers are kasi parang parang tinitignan siya as another way to cheat, no? But it's actually, in a way, it could be very useful because it is meron siyang venue to be, I don't know, meron siyang level of creativity na sarili niya, na na-train sa kanya, na we could take advantage of to do the more menial tasks like coming up with sample problems. So, if you're looking for practice exercises, tapos nagawa niyo na lahat na nasa libro niyo, okay naman siya to give us some. Although in this case, I'm looking at some problems. Yung iba dito, medyo hindi pa tayo ready to solve. Like yung number 10, yung may sine of x squared. Yung number 10 na may sine of x squared, that's a topic for next week. Yung dito, parang derivatives ng composite functions. But I'm encouraging you to, use whatever tools available to help you practice, including ChatGPT. Nagamit ko din siya pag nag-iisip akong problems. Then, inaano ko na lang Finifilter ko na lang kung ano yung nasa level na kakayanin natin. I want us to look at the graph of the exponential function. Kasi this is a very special function pag pinag-aaralan natin ang derivatives. Like, it's one of the most important functions na pwede nating ma-encounter. Tapos ang simple-simple lang niya, di ba? It's just an exponential function na always positive, asymptotic siya sa x-axis. Then paglagpas niya pag naging positive na yung x, mag-shoot up na siya. Also, yung value niya at x equals 0 is 1 kasi e to the 0, of course, that's equal to 1. Palitan natin yung kulay. Ayoko ng black. Orange. Okay. Now, let us imagine yung derivative niya. So this is not a formal proof, no? But sort of, since nag-i-imagine naman tayo ng derivatives, kanina, nung tinitignan natin yung sine and cosine, by observing yung mga slopes ng tangent line, if you look at e to the x, yung slope ng tangent line natin sa portion na to, they're more or less, it's almost constant, di ba? Ang flat niya eh. So, yung ina-expect natin na derivative nitong exponential function dito sa banda rito, it's also around 0, right? Then, the derivative will increase slightly, no, mula dito papunta rito. Na pagdating natin dito sa x equals 0, the derivative will be positive, like some nice positive value. Actually, baka nga pwede siyang 1. Like, I have the graph na, I have a line y equals x plus 1. Tapos tangent siya dito. So mukhang siya talaga yung tangent line to x equals 0 sa exponential function. At yung slope ng tangent line natin ay yung slope ng line, which is 1. Okay. Then paglagpas natin sa x equals 0, then it just goes up again. Tataas ulit ng mabilis. So I don't know if you're noticing, but the derivative of this exponential function will sort of behave like an exponential function. And you could actually graph it na what is the graph of the derivative of f of x? It's actually the exponential function pa rin. The derivative of the exponential function is itself. So, siya yung function na kahit anong derivative gawin mo, babalik at babalik pa rin siya sa sarili niya. Okay. So, we won't be deriving that yet, no? Sa classroom na lang yun kasi medyo mahaba siya. But I just wanted to introduce that kasi kung wow siya ngayon, paulit-ulit lalabas yan all the way hanggang saan kayo magmamath, either sa engineering or sa science.